So we now move from novel applications of computational techniques derived from biology to a related field, and Professor Philip Bourne is going to be speaking to us next. As you will hear when he comes up to speak, he's from far eastern Australia, currently based at University of California, San Diego. His professional interests are extremely broad, as you'll hear, covering algorithms, text mining, machine learning, meta-languages, biological databases, visualizations, and on and on. He's co-founded 4 companies, and most recently in his career, well, I say most recently, you've probably been worried about it all your career, but the last couple of years when I've heard him speak, he's been focused on how do we further the free dissemination of science through new models of publishing, and how do we do better integration between data and publications to avoid some of the problems that Professor Laubichler described. Phil Bourne is currently the co-founder and founding editor-in-chief of the open access journal PLOS Computational Biology, which is in some ways serving as a test bed for some of these ideas about open access. He's received many, many awards, including the Jim Gray E-Science Award, the Benjamin Franklin Award, the Sun Microsystems Convergence Award, and on. But you don't want to hear about his distinguished past, you want to hear about what he's going to say to us today. Please join with me in welcoming Professor Philip Bourne. Now, you're going to display now. Do you want that as the shadow display for you, or are you going to sit?
Put the glasses on. See what we can do here. Thank you. Well, thank you very much for inviting me here. It's a pleasure. I hope by the time I'm done you don't regret it. I have a feeling you might, but we'll see. Because I come from this from a very pragmatic perspective, and I'm actually going to talk to you. Andrew mentioned our work with PLOS, but I'm also going to talk about our work with the Protein Data Bank, which is a long-standing database. So this is really a convolution of what's going on with respect to the literature and with respect to data. And it's really about the best practices that we've come to, quite often by making mistakes, over the last, in the case of the PDB, I've been doing this for 15 years. So hopefully some of that will be relevant to the kinds of things that you're doing going forward, particularly what's going on in the working groups, I would say. So let's see if I can get this to move. So my perspective is, first of all, I'm both a data producer, a data maintainer, and a data user. There's nothing like trying to figure out how good, if you try to use the data you're maintaining, that's a real test as to how good it is. And I can't overemphasize how important that is. And I would say a lot of the best maintained resources are those where the people themselves are actually researching on the data they're maintaining. The curation is very much part of the efforts, excuse me, and I'll say a little about curation. I'm actually suspicious of a lot of things, which is why I think you probably won't invite me back. I'm suspicious of the endless stream of workshop reports we're producing. I shouldn't be suspicious of data standards bodies, but as you'll see in a minute, I have cause for this. Perhaps you won't. I'm certainly a supporter of data publication, and I'll say a little about what's happening in that space. At least all of this is drawn from the biosciences. And I think this is a whole new area that's emerging that really puts everything you're doing here into a real important perspective. And as was mentioned, I'm an open access advocate, a zealot probably, is probably a fairer statement. And as you already have probably got the idea, I'm fairly opinionated. So just to say that the part of my best practices comes from working with the Public Library of Science over the last 10 years now. If you're not from this area, just to say that this was a movement that started with 30,000 signatories in the belief that the biomedical literature should be more available. Probably over 20 to 25% of the biomedical literature is now open access. And these journals, including the one that I'm involved with, have actually really blossomed to the point where PLOS One is now receiving over 2,000 papers a month. This has now led to the coining of the phrase the mega journal, and of course the more traditional publishers are now of course also producing mega journals. The emphasis here, I have to say, is on community. These are community journals. They're driven by the community. And this is also true of where I'm also drawing my best practices, which is from this database we maintain. It doesn't matter essentially what data it is. It's actually the data on three-dimensional biological macromolecules. Just think of them as data objects for the purpose of this talk. But it is a global community. It's also 42 years old. It's been around a long time. It has a very diverse set of users. It is managed through community efforts to be and maintain itself as the single archive without fractionation. How that's worked in a global community is something I'll emphasize and tell you about. It also is used a lot. There's about 300,000 unique users a month. 7 data objects are downloaded every second from about 300 simultaneous users. So this is something that's built up from almost nothing to this very highly used resource, and it's that I'm going to draw the experiences from. We have evidence that this data is important and how it's used. So during the H1N1 epidemic several years ago, in the top right-hand corner, you can see the accumulative number of cases in the US. What you see on the bottom, those two graphs, are effectively access to 2 data objects that relate to H1N1 that are in the database. So their access is correlated quite strongly with the number of cases of the outbreak. So this is evidence that the usage of the data follows the need. And this is something, obviously, Google and others have been exploiting quite heavily with things like Google Flu and tracing epidemics by virtue of how people are querying in different parts of the world. So using data in this kind of way is, in a sense, a whole new frontier, and I'll say a bit more about that in a minute. So here's my little agenda. What are we seeing? What have we learned? What do we need to change? And what are we doing in our own little group to facilitate that change? So I should say that these, what needs to change is really a personal opinion that doesn't necessarily reflect the many organisations I'm part of. So what are the trends that we're seeing in these resources? Well, first of all, the trend in data access. The demand we have today, the way that people, is really driven by what people see in Google. We need to constantly maintain faster and more accurate access to our data. And I'll say a little more about that. We address that by search engine optimization, memcache, denormalization, improved query interfaces, all the usual kinds of things. Where we're seeing trends in the growth is in the use of RESTful services. So a few years ago, essentially, we weren't seeing, in the era of SOAP, we weren't really seeing much of that. Now, this is one of the fastest growing areas of our resource, is people pulling data on the fly into aggregated kinds of computation and the kinds of things that Manfred was talking about. I actually was expecting that the use of widgets would be much greater. So the idea that people would embed our widgets in their applications and in their pages where they were constantly on the fly pulling the data they needed for their own particular applications. That's not taken off as fast as I would have expected because it seems quite a compelling kind of use. I should say that essentially all of our data, so our data model, which has evolved over the years, and I'll say a bit more about that as well, all of that data is exposed through the RESTful services. And that's been absolutely important. So the way that, just to give you just a flavour of how this works, when the autocomplete feature, which of course has to be there because it has to be Google-esque, but what we do is we take that a step further and we break that down into certain categories of access that we know that the user base wants. And how we know that I'll get to in a second. But it's just an example where we've put enormous amounts of effort into trying to make the data accessible in the best possible ways. And we do advanced searching and other things as well. Another trend is, whether this is true or not, I have no idea, but Morgan Stanley has said that the use of mobile devices will subsume subsume desktops around now. I'm not sure whether that's true or not. What I do know is that the demand, it doesn't matter how big and complex the data are, people want to access them from all sorts of devices. And we've had a lot of demand to access our data on obviously smart devices. And we've spent quite a lot of effort. We now have an application in the App Store. We've had, I think, about 10,000 downloads. And I think this kind of model, I'll say more about where the app-like model, as it relates to data, I believe is going and what we're doing about it. But this is essentially what's happened so far. I won't say any more about that. Another thing that we've been doing is we found that there's quite a lot of interest in thinking about our data source, our resources, in the way that people think about social networks. And they want something that they're familiar with in different contexts. So taking the context of what they do on Facebook and moving it into what they do with biological data seems to be something that's appealing. So here's an example of that. As you perhaps well know, that one of the ways of looking at things in Facebook are chronologically, based on interactions that you had over times and so forth. So what we've done is to create an interface that provides data in the same way. So it's effectively a chronological view of data that you can move through in much the same way that you would on Facebook. So in this case, you could do it by author. So you could create all the data sets that a particular author has provided. You can chronologically look through that, or it could be a particular topic area where you can actually determine what the chronologically what happened in that particular topic area, and that seems to be popular. So these are just quickly going over things that have been happening. So clearly, the hardware model has changed. One of the things that I'm always struck with is we don't pay enough attention in academia to what industry is doing in many of these realms. And this includes, of course, the way we consider how we deploy services. So what we used to have is we used to have redundancy across the east and west coast of the US, where if one of our sites failed, it would automatically fail over to the other side with the same URLs and so forth. We've now moved to the kind of model, of course, that Google and Amazon and others provide, which, of course, is not just use of virtual machines, but it's also the idea that we now have global load balancing to provide this data, which we didn't have before. So there's nothing in any way revolutionary about this. It's just following along the trends that happen in industry, but way after they've happened in industry, so it would seem to me. So, but what I think we ought to be thinking about is, bringing some of the best practices that are going on in industry right now into what we're doing in academia at this point in time, rather than doing it retrospectively, which strikes me as what's happening most of the time. So, okay, so that's just a little more on trends. Our data over time, so this has been going since 1971, has got more complex. But in fact, what's happened is that complexity has begat actually more use. I would have thought that in some ways it would have actually led to less use. So by complexity, what I mean, these are actually examples of molecules on that graph. So you can see the growth of the data over time. So this follows the typical sort of trends that we see. And I should say, we have managed to handle the increased volume of data at an increasingly lesser cost over the years. And I'll get to a little about how that's happened. But in some ways, that's been a bad thing. Of course, in principle, it's a good thing. But in terms of funding, it's a bad thing. The better you do, the less money you get. If you're not actually doing so well, which was the history when we took this resource over 15 years ago, the agencies were putting more money into trying to improve it all the time. And so if you were doing not so well, you were getting more money. Now we're doing well, our budget continually gets cut because they think we can do just as well with less money. It's a little depressing. But in any case, the data has got more complex. And not only has it got complex in terms of the new methods have come along, the size of all of these molecules you see on the right are actually to scale. Many of those resulted in Nobel Prizes. So we've actually had to have a data model and a system that can embrace all of that over time and allow us to keep these costs down. So what have we learned in this whole thing? So that was sort of the trends we've seen. So what have we learned? Well, first of all, I mean, some of this is sort of obvious, but it always seems to me that it's worth stating. It's all about trust. I mean, when we took over this resource 15 years ago, there was huge, even though the same people that complained that how it was being run before was inadequate were the same people who wrote letters to Science and Nature complaining this is the end of structural biology as we know it. This will be a disaster. So starting from that point, it was, you really, ground zero, had to build trust. So how do you go about building that trust? And I think we've done that, and that's, to me, all of this is more important than any of the underlying technologies. So trust, first of all, is like compound interest. Once you've got a little bit of it, it starts to build more and more and more. So once you can get started, I think it really works. It comes from you build trust by listening to the community. It's always about the community. The community is engaged in every aspect of what we do. They define what we do. We're just the curators, the keepers of their information. They still feel like they own the data, but they entrust it with us. And these are big things. So as an example of that, there have been cases of fraud. So structures, the data actually has proved to be fraudulent. Our validation processes for this data, when it's provided to the resource, did not pick this up, partly because the data was too perfect. The atomic, the bond lengths, the bond angles of all these structures and things were exact. And that went through our validation processes because this was in principle good, but it was too good. So it's just an example of how we need to consider validation at different time points. We don't define how we validate the community's data. We create task forces of experts in the area that provide a recommendation, okay, it's a report, which we then enact. So, and that becomes the standard for the community that they themselves devised. We've essentially been the vehicle for that. I think, and I'll say a little more about this too in a second, it's all about data consistency and the quality of data, the responsiveness of us to our community. So, for example, we actually answer all requests from the community within 48 hours. Or 2 working days, and of course the quality of which we deliver the data. So, as I said, this trust comes from all of these things, but the data quality ultimately is the major facet of that trust. So we've spent about 25% of our budget, and continue to do so, remediating the data that we already have. Because what happens as we collect more data, we see variance in that data that points us to areas where it can be improved. And then we go back and we try and, with the community, we try and improve that. A lot of that has to do with annotation. But it's really, getting more data, and once you've got more data, being able to analyze that more, which tells you that there are discrepancies in the data, and going back. And we're not talking about a huge data set here. We're talking about essentially a terabyte of data. But we keep going back, and once we do that, of course, we version. And versioning has been important because when a version of the data is usually, not always these days, in fact less so these days, is associated with a publication. We need that copy of record. But typically when someone goes to a publication and they see reference to a data set, then they want that data set. What we do is we say, okay, this is the copy of record, but here is versions A, B, and C that have been created since that original version. And those are accessible as well. So if people actually really want to dig in and see changes that have happened to that particular data set, they can do that. So obviously it's all part of the provenance model and so forth. And of course all of that comes from having a really rigorous ontology and data model. We developed this long before the biological community ever got into the notion of ontologies, and it turns out it was quite complicated, but it is the foundation of everything we do. So from the data, from the data description itself, we generate all the different types of databases we use. We generate the user interfaces to input data, and so we have this one constant framework from which to work. And that's proved to be extremely valuable internally. But externally, the community our particular community didn't use it very much, preferring simpler representations. Only in the last year or two, I think maybe it's the sophistication of the user base, I don't know quite what, but certainly, even though it's a complex data model, it is now being embraced and used more fully. We did not develop enough tools to support our own data model for the community in the beginning, and I think that was one of the impediments. Now what we've seen is, particularly our own efforts, but also other open source efforts have really changed that and made quite a difference. So what else have we learned? Irrespective of everything else, it's about people. And I would say, in our case, we have a team of curators who analyze all input that comes from the community. And I would say that those people, not just those that do work with us, but as a group at large, really are the unsung heroes of what we're doing in science right now. Their contribution is, I think, really underrated. Unfortunately, and I tried to address this by creating in the journal we do, we have these things called collections where the biocurators could actually describe what it is that they do with data in different areas, in different disciplines. Unfortunately, right now in that collection there's probably, I think, 4 entries. So that they haven't been, I don't think they're doing themselves a disservice I think they're doing themselves a disservice by not telling the rest of us how much work they're really doing. And how important it is. I also think that these kinds of people are generally not well respected within the institutions. I'll say a bit more about this, but this is to me an endemic problem that, in other words, how data scientists are treated within the institutions in which they work. I think there's a lot of work to be done there. And I'll say a bit more about that in a second as well. There's obviously another aspect, of course, is the people who actually use the resource. So I just make a couple of points, what we've learned. Whatever we do, we essentially provide primary data, and then we have a set of derived data that is computationally acted upon. And once you act upon the primary data, there are different ways of doing that, different methodologies, often giving slightly different results. We try and distinguish to the user very clearly what's the primary data versus what's the derived data. And however we try and do that, color coding, flashing lights, whatever it is, the user doesn't pay attention. They just take, you know all this, we're all users as well, right? So it's definitely an issue. Also, all data are not created equal. There's no doubt that if you look at the data that's essentially describing the same thing, there are multiple data sets for it of different quality. But people don't pay attention to the parameters that tell them that these things are of different quality. They just use the first one that they grab. And trying to come up with ways to point users at the best particular data set for a task, These are challenges. These are certainly challenges I hope this group will be addressing. Now, here's probably the biggest thing of all. It's about personalities. I can't just... The reason, in my opinion, and it's not about me, it's about some of the people in this picture, that what we've been doing is we believe has been successful, at least at this point in time, is because of those personalities. And they've acted globally. So this is, I think, an important model that's come out of this particular data resource that I think is very important to RDA. And that is this notion of the worldwide PDB. This is a very important data set. I mentioned there's a bunch of Nobel Prizes. There hasn't been a drug that's really put on the market in the last 20 years that hasn't used this resource in some way to get to that point. So it's very important, and yet the data is generated worldwide. But to have a single repository in a single country run by a single country is just not acceptable. The problem is that the way that things are funded sort of pushes you into that model. So what happened in this case with the WWPDB is that groups in Europe, Japan, and the US, even though they're funded independently, the personalities involved in running the resource said, okay, let's work together to make this a global resource, even though our funding sources come from different places. And so it's the will of the people running the resource that made this happen. It would be really nice if the funding agencies, and there are examples of this, but not enough, were really allowing this to happen much more routinely, so that there could be this real sharing of responsibility. So how it works here just is quite interesting. So the three entities that make up, in the three geographically different regions, they each accept data. But they started off by using different data acceptance tools, but they used a common data representation and a common data dictionary to validate the data. They agreed on that, or we agreed on it. We all agreed on it. And that has now evolved over time to the point where there's a new, completely new deposition system that's been developed by these global entities together. And they've each put in resources to do this together. So that's a sign of collaboration. But at the same time, we are also competing with each other, in that once the data has been processed to the same standard, how we provide that data to the user is different depending in which part of the world or which of the resources you go to. So in that sense, we're competing. So that, and that's probably a good thing, because we try to provide a certain level of complementary services, but at the same time, we're always trying to outdo each other, even though we're competing on one aspect of the data. So it's a model, I leave it to you to decide whether it works, but from our point of view, it's something that's worked very well. This is actually a non-profit corporation that was formed. It's raising money, and I'll get to say something about business models in a second. What have we learned in all of this? I'd say it's not all about institutions. I have to say, and this is, and please correct me, but I can't think of in one way how a standard body in the last 15 years that we've been doing this resource has had any influence whatsoever over what we do. There's probably lots of subtleties under all that I'm not taking into account, but I think going forward, what you're doing with working groups, I would challenge you to work with us to have impact on what we do in the next 3 years. That would be, from my point of view, definitely making this long trip worthwhile. So I don't think we should underestimate the data sharing plans that the community, that the funding agencies have put in place in different parts of the world. This is, to me, a very important and really promising and wonderful step. I would say in this case, it's just another example of community. This community essentially enforced their own data sharing plan many years ago. By what they did is about 20 years ago, is they went to all of the publishers where this kind of data was published and said, we don't want you to accept any papers from us unless the data itself has been deposited in this repository. Well, you can imagine what happened. It just exploded overnight. And effectively what's happened is it collects all of the data that's associated with these publications. So there's virtually no journal that doesn't comply to this scheme. So that it was the community themselves that enforced that, and of course that leads to the data sharing that they enforced. So, these are good things. I think openness is a very important aspect to all of this. Manfred was emphasizing this as well. I won't go into, everything we do is with open source software. We contribute, I wouldn't say everything, but we should, back to the community through projects like BioJava, which we're responsible for. Where we're, I think, falling down right now, where I think there's a lot of opportunity in something that's going to drive things forward, is we're not transparent about how our data is used. I said to you, okay, there's seven data objects downloaded every second. All right? Well, that's transparency, but that doesn't really say how the data is used. One example, to just put this in perspective, is we know quite a lot. We know that when we can associate a data object with an IP address that's accessed that data object. So if that same IP then accesses other data objects and that pattern recurs, we know that. So we have the ability to say to people, if you looked at this data object, then this is Amazon, you should probably look at this one as well because X people did. We don't currently expose that information. There's some sensitivity to doing that, even though, and so it's an interesting question as to whether we should or should not do this. We have an advisory board. I want to do it. The advisory board is not so keen. But these are kind of, so how we interpret not the data itself, but the usage patterns of the data. This is, to me, in science, such an amazingly unexplored area. And we heard a bit about how that's happening, but some people are out in front. So what needs to change? Well, I think I've just said this. We need to understand how the data is used. We are in this situation. We hear about the fire hose. We hear about all these different. But the fact is, it's true. And people are talking about the problem, but they don't seem to be talking about the solutions. And I'm assuming that's a lot of what you're dealing with here. I would say that there's just the problem, and we've just got to go to industry to look at some of this because we don't have business models right now for sustaining the data that we're generating. I mean, the only business model I hear is we want more money from the federal government or the funding agencies to sustain this data. I don't think to me, that's not a business model. We're not broaching what needs to happen here, which is, looking at alternative payment models. And of course, those models can be open models where depositors pay to actually deposit. They can be models where people pay to, subscription models where people pay to access. And perhaps the most promising of all are models where, in fact, the raw data is free, but the services that are layered on top of that have to be paid for, which is exactly what's going on in the commercial world, but something that in academia we don't seem to be embracing. It also, of course, absolutely requires that we throw data away. We haven't even begun to, no scientist wants to think about the notion of throwing data away. But we're going to have to throw data away. And how do we decide that? Are we spending a lot of time figuring out the cost of actually producing a piece of data and what it costs to store it and maintain it versus recreating it at some point? These are questions in our own little community we're beginning to grapple with. And that also all relates to reductionism. And then there's the whole long tail problem, which I'm sure you're pretty familiar with, so I won't go into that. I think the institutions that many of us are part of, academic institutions, I don't think we're spending enough time worrying about our own data. We need institutional data plans. And I don't think, I'm at the University of California, San Diego, we're only beginning to talk about this. We don't have a chief information officer. We have a fragmented view of looking at this, and yet I think we need to start thinking about more collective ways of doing this. And part of that is to better treat our data scientists. There's been a lot of talk about this recently, at least in the circles that I move in. And part of it has to do with reward, and I'll give you an example of that in a second. Part of this, of course, comes from this distinction between data and knowledge, which is really merging. It's absolutely amazing to me what's going on in that I'm part of another resource where there's a team of people who extract information from the literature and put it in a database. There's a huge cost to doing that. And at the same time, the journals are collecting more data, whether they like it or not. And so we've got this blurring between what was formerly a publication and what's formerly in a database. And, it's interesting, and yet how we measure these things doesn't make any sense at all. Here's an example. So this database I've been talking about, the PDB, there's a paper about that database that was written in 2000. It's been cited 14,000 times. This is really cool, right? It really is a reflection of the value of that database. But no one's ever read that paper. There's absolutely no reason to read it because it doesn't actually tell you anything that's current. It's only there as a reference point to a data set. So why don't we just reference the data set and be done with it? So on the other hand, we've got a whole bunch of data sets now that have incredible value. What's more valuable, a data set that's downloaded by 1,000 people and leads to a whole bunch of publications versus something that I might write that only I ever cite? I mean, it's obvious that that data has a lot of value. And we don't have good metrics right now. And we're at fault for this. We're not producing good metrics. We could actually produce a thing. If you deposit data with us, we can give you a little widget that is updated automatically that you could put on your home page that says how many times your data's been accessed. It would be valued to you, and sooner or later, the institutions in which you work will pay attention to those numbers. I'm going on a real diatribe here. Okay, but I'm enjoying myself, even if you're not. We're in the biomedical sciences, I think we've done an amazingly good job at putting together data resources. Unfortunately, we're now at this point in evolution where those data sources have tended to focus on individual sources of data. But the questions we've probably always asked, but it's more paramount now in this world of translational science and interdisciplinary science, makes it actually more difficult to answer questions about those data. So the whole aggregation of data and levels of service that aggregate across data sets are obviously very important. And then I mentioned usage alone. So what are we, just to finish with, what are we contributing, or trying to contribute? So let me paint a sort of little scenario of where this sort of thing might go. So one thing is in the top left-hand corner there, you see a traditional paper, all right? So in that paper, there's typically a thumbnail of a figure. Right now, you go and click on it, you get a bigger version of that, all right? So that's okay, but really behind all of that is some very important future. Should enable you to do that very easily, because the metadata should be deposited with the article, and including where to get the data, and at any time you can use the journal article as an interface onto the data. And then of course when you do that, the data itself triggers questions. So you can when you interrogate the data, that by virtue of the fact that it's linked to other data sets and other literature, enables you to create a mashup of relevant information, which then drives you to more papers. So it's the idea that the data and the publication become much more interoperable. I mean, this is happening to some degree already, but there's a lot more to be done. I'm running out of time, but We're in the process of creating PLOS data papers which effectively do this. So the idea is important data sets can effectively be treated like a publication. So when you upload the information to a journal, you do for a paper, essentially you're doing the same kind of thing. The metadata is captured, the metadata effectively becomes a small publication. It's in PLOS, it gets a digital object identifier, it's in PubMed. It creates some value in a traditional system for that data set. And of course, it more fully, people will go to the trouble of doing that if they're getting a publication for it, and it fully describes the data set. These things are fraught with problems as well, but I don't have time for that. I'm only telling you the good stuff. So that's something that's happening right now. There's just a methodology. I've actually come from a meeting that's going on today in Amsterdam. It's called Beyond the PDF 2. It's really, I encourage you to look into the work of that group. It's called Force 11, where a lot of these ideas are being put into practice. So one last thing, we're also moving to the PDB, this particular data source, more towards an app model. So the idea is that we now have built this level of trust with respect to the data. Let's see if we can extend that so we create a level of trust around the applications that run on that data. So in a way, the data source becomes the equivalent of a smart device. Because what we will do is we will encourage people to provide applications according to a certain standard of user interface and so on that operate on that data. Why will they do that? Well, because they then register with us. At that point, people can comment on them, they can rate them, they can use, and they will use them. So those user statistics will feed back to the user, and it creates a new and different kind of environment for maintaining software associated with operating on these data sets that we hope will be more consistent and provide more credit to the people who produce that software than has happened to date. And we know that this is important. I've surveyed software that's used to operate on this data set, and I would say the attrition rate is about 10% per year. What I mean by that is you go to a paper that describes a method that operates on this data, and that paper has a URL. Within 1 year, 10% of those URLs are no longer working, and it goes up, and about 50% it levels off. So sustainability of the software associated with running on this data is a problem, and this is one way that we're thinking about trying to address it. So that's all I wanted to say. There's a lot of people involved in this, and I've tried to emphasize it's all about community and it's all about people. And I encourage you to look into the work of Force 11, which is really looking at new modes of publishing. And I thank you for your attention.
Thank you for an amazing talk, Phil. So many ideas. We've got time probably, well, we're slightly over time, but with people's forbearance, we might just take a couple of questions. Anyone brave enough? Okay, way up the back. I detect the silhouette of at Taswegian, one of our speakers from yesterday. Yeah, I know, it's always a worry.
And Andrew and I have been talking this morning, haven't we? Peter Fox, Rensselaer. Thanks, Phil. Rewind to about halfway through your talk, you talked about the curators. Can you say a little bit about, and I don't want their names, but who they are, what skills you've found they really need, and, where you get them from?
Okay, thanks, Peter. That's a good question. So first of all, there is an international society for biocurators. So they are working together. I'd say in our particular case, and in many of the biomedical areas, these are typically people that have PhDs. They really understand the data. Well, they need to understand that the data that they're interpreting. And they really are, as I said already, the unsung heroes. And well, I mean, I think that really says it all. But I think the career path for these people is a little problematic. And so that's certainly something that's where it comes back to the institutions. We don't value these people enough. And how all this pans out in the future remains to be seen. I can imagine what used to be the library and the people in the library. I can imagine lots of scenarios where these kinds of people form, in a sense, specialised communities around maintaining this data and have more of a structure that enables career path growth. But that's pretty much where it stands today.
And one more question from Hans Pfeifenberger.
Yeah, Hans Pfeifenberger from Alfred Wegener Institute. You used the metaphor of the journal article as an interface to your database, and also you are embracing this Force 11 thing. I see the last name on the list, which is from Elsevier, I think. Wouldn't you fear that the publishers again become the gatekeepers, and I mean this in a literal sense, between the users and the scientific knowledge, in the case of data as well, if you allow them to become the interface?
Ooh, you're opening up a lot of stuff here. I love it. Well, first of all, as I mentioned at the beginning, I'm an open access advocate, but I always preface that by saying I'm also a realist, and there has to be a business model. I think there's a very important role for publishers in what we're doing. I just think it's probably a very different role, or certainly somewhat different role, than what they're currently providing. This Beyond the PDF meeting, which is going on right now, yes, Anita de Woord is from Elsevier. There are 20 people, I think, at this meeting from Elsevier. They're starting to pay attention to, again, what the community has driven in this change. The change started with open access, and now it's moving into data. It's moving into a whole set of new digital assets, as I would put it, that we haven't really dealt with before. And I think you could argue in some ways that the publisher of the future should be maintaining the data resource that I currently maintain as a researcher. And that's when so. It's just a thought.
Yeah, okay. We're rather than eat further into morning tea time, we should stop there for questions. Françoise Geneva has generously agreed not to give her question so that we can get to them. Yeah, but Phil doesn't escape. I think you'll agree that this has been a wonderful start to today. Please join with me in thanking both of our speakers.